Hey, Sunshines. So we are working on the segment addition and angle addition postulates. So this proof is an angle addition proof. It works the same way as the segment addition ones. I stuck this question in here because it was a little bit easier, but I forgot that it had the option to do angles, even though we didn't go over angles yet. But it works exactly the same way. You just use the word angle instead of the word segment. So the idea of this question is you're given two pairs of angles that are congruent, and you want to prove that a third pair is congruent based off of that information. So conceptually, angle QPS is this one is congruent to angle VPT. So these two are the same. And then angle 1 and angle 3, so that's these little guys in here, are the same. Well, if I subtract the same number from the same number, so if I subtract 3 from 5, that's going to be the same thing when I subtract 3 from 5 on this side. So if these are both x and these are both y, then this little angle here is going to be x minus y. And this one here is going to be x minus y. So it's going to be the same thing. And so my goal is that I want to prove that. But because this is a formal proof, we got to be all fancy schmancy about it. We can't go saying x's and y's. We got to do it formally and use all of their proper names and stuff. But that's what it comes down to, is that we're going to then use the addition postulate, the segment addition postulate, or sorry, these are angles, the angle addition postulate, and then we're going to use those equations properties. It's just that instead of subtracting numbers, we're going to be subtracting the measure of angle 3 or whatever. So I need to go through and look at all of my reasons. So angle QPS is congruent, or sorry, not as angle QPS, the measure of angle QPS is equal, not congruent, equals. Numbers are equal, things are congruent. So when you're talking about the measure of an angle, that's a number. If you have the little m in front of the angle sign, that means you're talking about a numeric value, how big the angle is, and quantities are something that you can add and subtract. You can't actually add and subtract physical angles, those are objects, but you add and subtract their measurements. So the measure of angle QPS, that's the big one, equals the little one plus the other little one. That's the angle addition postulate, or property, according to Alex, same thing. And then same thing on the other side. Angle VPT is the big one. It equals the sum of the two little ones. So this is the same thing as the segment addition postulate or the segment addition property that we talked about. It's just that we say angle when we're dealing with angles instead of segments. And then why is angle QPS equal to the measure of angle VPT? Because it says so up here. And if it says so up here, that means it is given to us. Which incidentally is also this one here, angle 1 and angle 3. So usually when I write out a proof myself, I start with the given information because that's the easiest thing. I know that it's true. I don't need to know anything else before I know that it's true because I was given that. Now this one here is where it gets a little bit complicated. Angle 1 and angle 2 are the same thing as angle QPS. Angle 3 plus angle 4 is the same thing as angle VPT. So what we're doing is we're just replacing it with something that's the same. So that's called substitution. So all we did was just trade out those values. And then we're going to talk about angle 1 and angle 3. We just said that's because it's given. And then, well, if angle 1 is the same thing as angle 3, where's another color? We said angle 1 is the same thing as angle 3. So I can just replace angle 1 with angle 3, and then everything else in the statement stays the same. So that's substitution again. Now I have the same thing on both sides, and I can subtract angle 3 from both sides. So if I take away angle 3, I lost the M, then I'm left with measure of angle 2 equals measure of angle 4. So when you subtract the same thing from both sides, that is the subtraction property of equality. So addition and subtraction, because really addition and subtraction are the same thing. It's just one is positive, one is negative. Multiplication and division are really the same thing. Dividing is multiplying by a fraction. So addition and subtraction properties. And then we click our little check button and make sure we got it right. Yay, we did. And then all my little markups got lost because the page moved.